Hi, in this mini lecture, I will talk about electromobility. First of all, I will give a definition of electromobility. I will continue with discussing some of the technologies involved in electromobility, the drivers and barriers to electromobility, and lastly, the environmental performance of electromobility. Electromobility can be defined as a road transport system based on vehicles that are propelled by electricity. This includes vehicles that can be propelled with electricity that they produce themselves, for instance, hybrid electric vehicles, or vehicles that use electricity from the outside, usually the electricity grid. If electricity is provided to the vehicle by the grid, this means that the vehicle can use energy from many different sources, both renewable and non-renewable, and almost anywhere in the world. This implies that electromobility may improve the flexibility and environmental performance of the transport sector. This figure shows different energy sources and different technologies to transfer the electricity to the vehicle, that is, to charge the vehicle. The main way to charge a vehicle is using an electric cord or via wireless charging while it is parked. Rapid chargers can also be used in order to extend the driving range of the vehicle. Batteries can also be switched, that is, discharged batteries are replaced with fully charged ones. It is also possible to supply a vehicle with energy while it is in motion. And lastly, hydrogen can be produced via electrolysis and stored in tanks. As shown in the figure, each of these technology options have their advantages and disadvantages. Some hybrid drivetrain versions are also shown in the figure. A drivetrain is the system in a vehicle which connects the transmission to the driving wheels. Hybrid drivetrains are used to overcome the limitations of one type of drivetrain with the strengths of another drivetrain. The types shown in the figure are battery electric vehicles, continuous power supply electric vehicles combined with electric road systems, and fuel cell vehicles. There are both drivers and barriers for technology development related to electromobility. One of the drivers actually was the financial crisis in 2008. National governments had to step in to prevent car companies from going bankrupt. The resulting support packages demanded that large amounts of money be spent on green technology in order to make vehicles less oil dependent, for both climate and geopolitical reasons. Another driver is that society needs to create new industries that in the future contribute to its economy. The largest barrier is that society and infrastructures have over time been adapted to the use of oil through, for instance, oil extraction, refinement and distribution, and work commutes by car to and from the suburbs in large urban areas. Furthermore, so-called lock-in effects make it difficult to make changes because such systems mutually reinforce themselves. This leads to low incentives for consumers to make changes because there are many advantages of using conventional oil fuel vehicles. There are also drivers and barriers of electromobility from a user perspective. Among the drivers are the economic reasons due to the low running costs, technology interest and curiosity, environmental concerns such as reducing air pollution or global warming, political reasons such as the dependency on foreign oil, and the excitement of friends and family. Among the barriers is what is popularly described as range anxiety. That is, people are concerned to get stuck in the middle of the road with no power left. This anxiety seems to diminish when the vehicle is used over a longer period of time, because the users get to know the vehicle better and know what trips are possible under given circumstances. Another barrier is people's perception of electric power, electronics, and batteries to be complex. People also have little experience with electric energy measurements, which affects their understanding of important aspects of driving an electric vehicle. The environmental performance of electric vehicles can be studied with life cycle assessment. A well-to-wheel study is one type of LCA, as shown in the figure, and focuses on the energy carrier used to propel the vehicle. For instance, liquid fuel or electricity. A well-to-wheel study can be split up in well-to-tank and tank-to-wheel phases. The well-to-tank phase consists of the delivery of energy to the vehicle, while the tank-to-wheel phase consists of the operation of the vehicle. The environmental burden of the well-to-tank phase depends on how the energy carrier is produced. For example, the difference is large between electricity produced from hydropower and coal-fired plants. In the case of liquid fuels, the tank-to-wheel phase includes both exhaust and evaporative emissions. For pure electric vehicles charged from the grid, the tank-to-wheel phase involves no emissions at all. The environmental benefits of electromobility will depend on the development of renewable electricity, as is shown by the results for global warming in this figure. In this figure, BEV stands for battery electric vehicle and ICEV stands for internal combustion engine vehicle. If electricity is produced from non-renewable resources like coal, oil, or natural gas, electric propulsion will mainly lead to problem shifting and substantial greenhouse gas emissions. Besides the renewable electricity sources shown in the figure, that is wind power and hydropower, electric propulsion allows us to tap into the vast energy resources provided by the sun and could thus enable a sustainable global transport system of current proportions or larger. Note also that from a global warming point of view, nuclear power is a feasible alternative. However, other significant environmental problems are connected to this source of energy. Electric vehicles are not inherently less safe, more expensive, or more complicated than internal combustion engine vehicles. However, they will require the same amount of knowledge and experience that has accumulated around the conventional internal combustion engine vehicle and an adapted infrastructure.